Hey, what's up guys? We're here at the brand new Starling HQ in Bristol in England, and I figured I'd take the opportunity while I'm here with Joe to go through the different steps in the process of building a bike from the raw tubing all the way through to the finished product.
Okay, I'll keep talking, but ask questions as we go along. So
Absolutely.
I suppose what we're talking about is this. So these are our Starling front triangles. So for our three core bikes, the Murmur, the Twist and the Swoop. So different wheel sizes, but they all use very similar front triangle, this kind of configuration. So I'll talk you through, the process that we used to make it here in our workshop in Bristol. So that's the frame. Pop that down there. The first step is to get the tube. So we use Reynolds tubes for the down tube and top tube. This is a raw down tube. Come in boxes, we've got them all stacked over there. First step is to actually QC it. So we take the tube, we check it's straight by rolling it on our surface table, and quite often they have a slight bow, so we always align the bow in the plane of the frame. Right. That just helps, but it's ever so slight, but it's just good to do that. And we check the butt position, so we check that the butts are where they're supposed to be. So a butted tube is thick at one end, thin in the middle and thick at the other end, so it's thick where you weld it.
Yeah.
And then select all our tubes. So we've got a 38.1mm down tube, 38.1 inch and a half, 31.8 top tube, and then the seat tube is actually not Reynolds tubing, it's 4130 tubing, and that's because it was the right diameter because we have to put a shim in it.
Yeah.
But it's pretty much the same tubing as they use at Reynolds, but just not heat treated.
Cool.
So from the raw tubes, the next step is to miter them. So mitering is really taking the tube and putting a curve in it. So putting the curve in it so that it joins to the other parts of the frame. So that's the top tube. So at the front, it joins to the head tube like that. And at the back, it joins to the seat tube. So we use a machine, which is an abrasive notcher, which is in our dirty room there. So we'll show you that in a bit.
Yeah.
And that essentially is it's just a big belt sander, and you have different sized mandrels, and you set the angle right, and then you just bring in the frame and miter the frame up to the right. And it's important to get the right angle, the right diameter, and the length.
Yeah.
So that it's the perfect length. So we do that for the three main tubes.
And you've got jig set up for that to make sure it goes into the right position every time? Or?
You have to set it up each time, so you
Right.
set the machine up. So that's why we tend to do batches. We do batches of 10 of each size at a time. And just because there's that setup time, doing batches more efficient.
Sure.
We've got a new notcher, which we're sort of going to commission soon, which is a bit more accurate and a bit easier to set up, so that'll help. It's got dials rather than, the way, it's very accurate at the moment, but it's a little bit time consuming.
Sure.
We want to be better. So once you've got the mitered tubes, there's also worth noting the down tube, for where the main pivot is, we've got this machining, the down tube actually has a flat miter on it, so it's just a flat cut, so that it welds nicely to the machining. So we've got a specific chop saw that we've set up to be able to do that cut. So that's just slightly odd. Not many bikes have got that detail. Mm-hmm. So then when you've got your three tubes, you then stick them in the jig. So we can see the jig. So you stick all the frames in the jig. The jig holds all the tubes in the right place, so that it looks like the bike frame. So you hold but an important feature of our bikes is the bottom bracket, the main pivot and the seat tube is the same on all our core bikes. Other than the length of the seat tube, all the angles and the positions are right. So if you imagine, the only thing that changes is the head tube. So if we're doing a bigger bike, you just move the head tube forwards. If we're doing a shorter bike, backwards. If you're doing a 29, the head tube is higher. If you're doing a 27, the head tube is lower. So all the changes in sizes are just by changing that head tube position.
And then I guess you have different angles on the tubes to set them to the right place, or?
We've actually just got holes drilled. So
Right.
we've got all the standard sizes drilled as holes on the jig. So it's all set up. So it's really simple. And then the shock mount as well, we've got the position of the shock mount mounted. So it's as simple as it can be, and that's key. And for manufacturing, it's really important. You take the tubes, stick them in the jig, and then tack it together. So a tack is a small weld. So we braze our frame. So brazing is using brass rather than a TIG, which is melting steel in there. So you braze the frames, and we just put small tacks 4 positions on each tube joint, and there's a very specific process they use to tack it to ensure it all pulls in the right directions and it doesn't distort too much.
Yeah. Why do you braze rather than?
Personally, I think brazing is better. My background was a stress engineer. I see a TIG joint, which is a very small, stiff joint, and you put a lot of heat in, and to me, it's a higher fail. It looks like something that's going to fail more than a nice, big, soft brass joint. If you're joining things together, putting a big, soft thing in there is actually good. It makes it more damage tolerant. Well, you've got a stress background as well, haven't you? So
sure, yeah, less high stress points.
Yeah.
Good.
Yeah. So, and yeah, I don't know. Brazing just makes sense. A lot of damage tolerance, roll cages and stuff quite often use brazing. Lots of old motorbikes use brazing. So yeah, I like it. People can argue about it forever. Yeah. Like what is better? People can argue about it. I like brazing. I'm happy to use it. We do TIG some joints. So this bottom bracket is TIGged into our main pivot machining because they're both quite thick metal structures. Yeah. To get the heat into brazing it is actually quite hard. We probably have to have some kind of, we've done it, but it's quite time consuming and it requires a lot of heat. Cool. Whereas to TIG that joint makes a bit more sense. Yeah. So tack all the tubes together, so that holds the whole frame together. We tack on the shock mount at the same time, and then we take it out of the jig and we align it at that point. So it's all held together, but not strong enough to ride, just held in position. Yeah. So then you actually use this surface table here. We stick the head tube in. I'll show you quickly. I'll show you on this frame. Wind that in. So we know that head tube is perfectly parallel to that plane. We have a little jobby that sits here. So that sets this frame at the same height as that. Yeah. And then all we have to check is that this seat tube is the right height from there. Yeah. And we know that this main pivot's right. We've checked before that this main pivot and bottom bracket. So it's really simple alignment step. So we do that alignment step. First of all, we tack it and then we align it. And then we braze up the head tube joints and then we align it. And then we braze up these down tube and seat tube to main pivot joints and then we align it. And then finally we braze up and align this joint. And even the brazing stages, there's lots of process to ensure you do. The boys who do the welding will tell you better. I haven't done it for a while. Brazing, I haven't done it for a while, but there's a process they go around to ensure that each joint pulls in the minimum amount to get it right. Yeah.
And what happens next?
So at this point we've essentially got what looks like a frame and it's all welded together. So it's just doing all the finishing touches really. So the shock mount we actually tacked on in a jig, so we have to weld the shock mount on. So we braze the shock mount on, and then we have to put on all the other finishing touches. So we've got this head tube gusset, which is a reinforcing kind of member. Other companies do it in different ways. They put little doublers, but I actually did some fem work a while ago and showed that a plate type doubler like this, or gusset like this, actually makes the two tubes bend together. So it's like an I-beam. So my old job, I was an aerospace stress engineer, so we were looking at the strength of structures. A FEM is the modelling the structures to see how they behave. Yeah. And a lot of time it's a lot of rubbish used for marketing. But if you're doing very specific problems and understanding it, it's a very good tool. So in this case, it was a really good tool. And it showed that this is a good solution. Yeah. So we actually use something called metabraze, which is some of the joints we use silver to solder them on. So the cable bosses, bottle bosses, this stealth port badge, we actually use silver and it's got a very low melting point, so it flows nicely, so you can put it on. These joints use something called metabraze, which is halfway between silver and brass. Okay. And because they're quite thin plates, it flows nicely. It's really good. So we fit those in place. Cable guides. There's cable guides on the bottom here. This nice little stealth port badge, which is where the dropper cable comes out, and there's also a number badge. And then that's really the whole frame welded up and done. So that's the frame finished, other than...
But this one's had some tidying up work done, right?
So then there's the tidying up work, which bizarrely takes a long time. You forget about all these stages. So reaming and facing the head tube. So that's really getting this. So as you weld it, the head tube distorts shape. It goes oversized slightly. So you then put in essentially a big drill bit which cuts it to exactly the right size and makes it perfectly circular.
Yeah.
And we face this top face here, so it's perfectly flat.
So your headset sits in it nicely.
Yeah, well, both faces.
Yeah.
Same with the main pivot. So this has got threads in it, but then it's distorted a bit, so we chase the threads out again.
Yeah.
This main pivot, this distorts a tiny little bit, so we run a reamer through here again to get this perfectly good. And then the final thing is the seat tube insert. So yeah, one of these. So previously we had just steel seat tubes without an insert. Unfortunately, aluminium seat posts galvanically corrode into steel seat posts. So you get this electrochemical behavior where the steel and aluminium bond together. So we've had various people with their seat posts bonded in. And if you keep on top of it, it's kind of okay, but people always forget, and especially with dropper posts these days.
Yeah, and
so
leave it in your frame over the winter, come to move it in height or change it in the summer, and then it's stuck in there.
So you can generally get them out with a big vise and a lot of strength, but people haven't got those things. They might have the strength, but not a big vise. So on our new V3 frames, we've gone with these aluminium shims. So we actually bond this shim in using epoxy. And then we ream it out afterwards. So because there is a little bit of distortion here, the shim might go in slightly wobbly. It might go in, well, not wobbly, but it might distort a little bit.
Yeah.
So we then bond it in, and then we actually use the lathe now, and we ream it out so it's perfect size. And then that's pretty much it. And then it's just really clean up. So there's a few, like just cleaning up these faces where the silver might have splashed over a bit, just checking all the welds, making sure all the brazes, making sure they're perfectly smooth. Just cleaning off all the flux.
And I guess, so one thing I think people maybe struggle to appreciate is that these are processes that, regardless of whether you make them in the UK in a small facility, or if you take it and you make it in China in a huge factory, you still have to go through these processes, right? Yeah. It's not unique to a slightly smaller operation, hand-built frame.
No. I suppose the difference is that we're doing smaller batches, so we can do custom options a lot easier. So we do custom bottle boss options. We can do custom sized frames if anybody wants that, and that's relatively easy. And we can change our designs a lot quicker, whereas if you're making 1,000 or something, the other thing is if there's any issues, if they make 1,000 and there's an issue,
you've got 1,000
frames with a problem, whereas we're doing small batches, we keep on top of it.
And I guess it would also be fair to say, because you're a smaller operation and they are your bikes, it's not just something that you're making for somebody else, you're paying more attention to the quality as well, right?
I think that's a really key point, actually, that the amount of thought that has gone into the manufacturing of these frames. Jeff and Ollie here, every day, all their discussion is how do we change that, how do we make that better, how do we do that, whereas all the big factories are just making to a drawing, and they've got their processes because they've been making bikes for a long time, but it's not specific to that particular bike. So the amount of hours spent thinking about how to build this is unbelievable. It drives me mad. It's like, just build them, stop talking about building them. But it means it's, the fact this is a TIG joint, that's a brazed joint. They've thought about when things need alignment, how all the detail about going through the weld processing. It's just, so much time and thought has been put into it. So, at the moment, this as a product is lovely. It's such all my bikes, everything is about simplicity and sort of elegancy and making it, as minimal effort as possible. And I look at this and it's as good as it gets, really, which is, makes me really happy. I can't think what to do to make it better. It's such a nice, elegant, not only design but manufacturing solution as well. So
certainly seems like it. Yeah, so I guess what does separate at the end of the day your frames from those made in a bigger facility elsewhere in the world?
So I think, as you said, all the factories are using the same processes and things, but they're making bikes for lots of different companies, different designs all the time, whereas we're just working on this one frame, and this has evolved over 5 or 6 years now. Boys in the workshop have spent so long thinking about it and talking about it and all the details about how they're going to change and improve it. And my design philosophy is simple and elegant, and that's what I've always aimed at. And I look at this as a product, and it is as simple as elegant as I can make it. I can't think of ways to make it better. I can't think of ways to improve it. So yeah, I'm happy. It's almost not being able to think of ways is bad because the industry expects continual change, but I think we've done a good job. It's such a nice product, really.
Yeah, it certainly seems like it. Thank you so much, Joe. It's been really interesting, and I hope you viewers have thought the same. If you have, then give us a like, leave us a comment, let us know what you think of the Starling frames, if you've found this kind of content interesting, and subscribe to the channel to see more awesome content on awesome bikes by fantastic manufacturers like Starling. Thank you very much for tuning in, guys. Catch you out on the trails.
Thanks, Rob. Cheers.